Welcome back, everybody. Now we're talking about intelligence and consciousness. This is chapters 9 and 10, so remember these chapters are not aligned with our lesson numbers exactly anymore, but that's okay. We're at week 8, even though we're on chapters 8 and 9. So anyways, these also don't seem like they may go together, but intelligence and consciousness are highly related. Intelligence is sort of the idea of our processing power and the connections that make that possible, whereas consciousness is what some people think is the byproduct of these connections. So sort of a ghost in the machine of the machine having this ability to process information. Now there's this sort of higher order uh, witnessing the processing, if you will. But starting off on what is intelligence, right? Well, of course, it's difficult to explain what intelligence is, but it's often described or measured by our ability to adapt to information, respond to information, judge and comprehend scenarios, right? A lot of these are almost scenarios, even though they're very numerical or graphical in nature. But we try to measure it. We've been involved in this. And in IO, we actually were some of the first psychologists, because early IO psychologists helped with what was called the Army Alpha and Army Beta tests. There's tests that were used to place people within military service during World War I and World War II. And those, sort of became also vocational tests. So if you take the ASVAB, that'll tell you, maybe you should be a mechanic or maybe you should be an architect. Those things are sort of related to these Army Alpha and Army Beta tests that were developed back then. You'll hear about divisions, the fluid versus the crystallized. The fluid being that processing power that I referenced earlier. The crystallized being more the facts and knowledge that you know. So, for example, the artist down below, he may be able to report previous artists like Dali. I'll mention Dali in a few slides if I remember. Different people, that may have influenced him, but then he may be applying those exact skills, but then adapting those with other styles or creating a new style, which might be more the fluid intelligence side of it. Anyways, different theorists tried to explain this in different ways, and these dates are all after the World War I, World War II timeline in the 20s and whatnot, and then 40s. So in between, maybe Thurston was working on this stuff. Spearman is an example of someone who thought there's this general idea, this G factor, that explains sort of differences in intelligence, whereas Thurston and Gardner are associated more with the types of intelligence. And so Thurston had 7. Gardner has, I think, the ones that are displayed there, being the musical, body kinesthetic sorts of things. So are you body smart in this sort of translation of it? Musical, for example, I would be music dumb. I am not good at music at all. But maybe I have more maybe verbal and language skills. Maybe I'm more word smart. I'm not sure that's true either, but moving on. It's important to point out that Spearman, even though he argued for this G factor, this general ability or processing power, which I like to relate to, early computers. It was all about it, whether you had an Intel chip and how many, megahertz that could process. That's sort of the brain in a sense. So G represents that Intel chip and your ability to handle information or, pull up information and apply it in certain ways. But even Spearman thought that you had sort of specific aspects of this that may be aligned with mechanical sorts of tasks, logical, spatial, and you may not be good at some of these specific tasks even though you have a high G. So he still sort of argued that there was types. Where does this come from? Well, before we measure it, I think it's important to point out that, there's different factors that lead to differences in intelligence, right, or individual differences in intelligence. There's, of course, heredity. Many different types of genes contribute to this in different ways. It's not one specific gene. They look at this through twin studies. I think some of those most interesting studies out there where they track, identical twins, monozygotic and dizygotic, the non-identical twins, and then where individuals were adopted into families to look at the influence of that nurture side of it in the nature and nurture debate. And you can explain some variance, some differences between people based on the number of genes they share, the percent of genetic information, I should say. And then, of course, like we say, there's these gene-environment interactions. So when you look at environments that can be more or less enriching, like when we talk about development, we talked about the, you know, the lack of any language stimulus in the environment can, especially during that critical period, can be very damaging. Whereas, of course, enrichment programs can be facilitating of development, right? And that's why in childhood, probably they're measuring our intelligence nonstop. If you remember back in elementary school, you were probably given more than one intelligence test. The Alfred Binet was one of the earliest Stanford Binet intelligence tests. Binet worked with a guy named Theophile Simon that I'll mention in a second. There's the Wechsler intelligence test, of course, pictured there with the different sort of images or puzzles that you put together. And I think it's all about the speed and the completeness and that sort of thing. But IQ is beyond that. It's really your ability to learn. So it evolved into more of a measurement to predict someone's performance, right? And so they started developing tests based on age to see where someone should be developmentally. And that was kind of what the Stanford Binet was used with for a long time, I believe, is, seeing developmentally where your child stands. One of my mom's favorite stories is that they gave me intelligence tests because I wasn't very verbal as a youth. So the graduate assistant probably was giving me these sort of standard tests per grade level. And the professor came back, and my mom's watching through this two-way mirror. And the professor says, "Oh, are they still doing the test?" And my mom says, "Yes." And he's like, "Oh, well, what grade are they on?" And, it was like high school at this point. And I was like, 2 or 3 or something. And he was like, "Well, I don't think it's, I don't think it's that he's not smart enough to talk. He just doesn't want to talk." But yeah, so these are based on age level, more so, and grade level, more so than anything else. It's a comparative sort of thing. But then they, developed the adult versions of these, of course, so they're different, and, both provide multiple types of intelligence, being verbal and sort of that processing sort of thing, using things like these matrices, which are nice because the Ravens, at least, there's a Ravens progressive matrices that are sort of culturally non-bound. So your ability to process this information, looking at these squares in this example, and seeing what would go next is sort of your ability to sort of see the rotation of that block box going around the other one. If you don't know what comes next, then you don't pass this item. And there's a series of these, of course, such as that human face you saw in the box earlier. Anyways, this has evolved to sort of what most people use in research settings, like me, where we're looking at some sort of what we call standard deviation IQ, or an IQ that's standardized along a normal distribution, where we have, standard deviations of intelligence. You can look at, +1, +2, +3 standard deviations above the mean as sort of rankings or bands of intelligence, right? The nice thing about this is if you have standardized tests, you can compare scores across people and with other constructs, maybe like I'll reference SES, socioeconomic standing. Things like that are very predictive of intelligence and things that give you opportunities to enhance that intelligence. Anyway, so standard deviation IQ is also important because you can look at sort of the quality of that measurement for that time, for that sample of people you give it to. And these are normed, just to look at that sort of average performance that can change over time. So you want to see the reliability and the validity of these tests over time to make sure they stay that way. Reliability being, when we talk about measurement theory, that's the repeatability or the consistency of all sorts of aspects of this test. Reliability can change, so you need to continually assess that and, adjust norms and stuff like that accordingly. But the reliability is really at the item level or at the test level. When you're looking at the test level, you're talking about whether test, retest, scores show consistency. So if I take the test 10 times, am I getting crazy scores like 90 and then 130 and then 100 and then 150? If my scores are all over the place, it doesn't look like that test, which is supposed to be assessing something stable, is really able to do that. Validity is kind of a different idea. It's looking at whether it's actually testing intelligence, right? Or if it's a job satisfaction test, like in my field, whether those items are actually asking about someone's job satisfaction, or whether they're asking about something a little different, right? Maybe their motivation or their maybe commitment, but not satisfaction. Anyways, why do we look at intelligence still? Well, it predicts a lot of things that are important in life, right? So I have a graph down there about IQ and income. Generally speaking, the higher you score on an intelligence test or an IQ test of some sort, it's going to predict the level of income you attain, or at least they're correlated, right? I'm not sure if it's predictive in the sense that I'm not sure we followed people from youth, even though this says predicts. It's correlated, let's say, or they seem to be co-occurring. And this also then is a self-fulfilling cycle of getting more opportunities if you have higher IQ and, are starting to do well to begin with, right? We see differences, it's important to point out, based on race and ethnic differences related to achievement in this regard. Most of this, or at least some of this, can be explained by what we call stereotype threat in psychology. And so this is sort of the perceived stereotype or perception of risk based on that stereotype that someone could perform badly. The classic difference is actually with gender, where women are told that they're, let's say, expected or stereotypically bad at something like math. Well, if you tell people that before a test, of course they perform bad, whether that's a distraction thing they've argued in the literature or something else internal. That's that sort of fear of succumbing to that stereotype. And there's ways to address this. I know focusing on strengths and things like that are something people do to alleviate stereotype threat. So before midterms, I always tell students, think about something you're good at, more so than think about those last couple things you're trying to memorize. Just do a confidence boosting thing. And whether it's because you're female or male, or let's say a racial and ethnic difference group that's maybe stereotyped to do bad in that area, then hopefully that'll assuage that a little bit. Anyways, a lot of this is changing due to changes in environment, education, family size, or less size, we should say, and increases in health and nutrition, and the availability of more, health, medicine sort of treatment, as well as food and nutrition sorts of stuff. People argue there's sort of, differences here based on race and ethnic differences, but generally speaking, that's not accepted by most scientists. It's explained by a lot of different socio-environmental factors. Programs that are available, once they are available, seem to narrow these gaps, which is nice to see. The Flynn effect is referencing this idea that just future generations tend to improve on IQ tests because of the improved opportunities and health and all that sort of stuff. So I think the socio-cultural context is almost more important than anything else. And of course, I have to point out that SES, socioeconomic status, income, tends to predict almost everything in terms of intelligence outcomes. Anyways, consciousness is, like I said, that sort of experience of the brain doing what it does, right? So some people call it a private experience, right? That's hard to measure. So behaviorists want to look at the behaviors that stem from that. But we've developed all sorts of ways to look at consciousness or conscious thought from, literally describe what you're thinking as you're doing something, to controlling stimuli or the way we think or attend our attention to a stimulus, to all these sorts of ways that we're measuring brain activity with the MRIs and CT scans and things like that. So we can really develop really interesting questions and have really operational or exact measurements of consciousness that can be tested. Hypotheses can be developed to test these ideas, which is really key to empirical psychology, right? So anyway, so we think about consciousness and action, right? So in terms of like, let's say moving your arm, that conscious experience of just moving something, we see the brain is actually much more involved in that at an earlier stage. Before we can really even say that we're moving our arm, our brain is thinking about that action. Where our voluntary things, the things that we're thinking about, so think back to those nervous systems, right? The different systems that handle different things, right? When we're thinking about doing something, it's a series of steps there that happen. Like I said, theorists argue that consciousness itself is really, it's a byproduct. They call this an epiphenomenon. So it's not really supposed to be there, if you will. There's no purpose to our conscious experience. So thinking to, squirrels or let's say like a fly, you may think a fly really has no conscious experience. It's just sort of doing what a fly does, or a squirrel does what a squirrel does. But especially children can imagine that inner workings of a conscious experience of a fly that may or may not be there, right? Anyways, when we don't have consciousness, right, we call that either literally the brain has no reaction, no activity. Comas sometimes have that low activity. And then vegetative states, of course, they, really have limited responsiveness, and they can sometimes experience pain because they see the heart rate increase, but they're basically in a coma type state. And then sometimes you can have, minimal consciousness coming in and out of a conscious or vegetative sort of state. They call that minimal conscious or minimally conscious state. When this is sort of done to you, we call that hypnosis, right? So that condition where you're sort of suggestible and maybe almost in that sort of limited conscious state, where you can recall things and can do activity behaviors, but may not even remember them, right? So they use hypnosis for a variety of things. For pain, of course, to stop smoking and other bad habits, and even to improve memory by what they, I think, integrating or placing subconscious thoughts into the mind that maybe they don't think about while waking in their conscious activity, but are embedded in there potentially. Another sort of influence on our conscious activity is our circadian rhythms, right? That balances our level of consciousness, if you will. So it's the level of activity we feel consciously that controls when we want to go to bed, when we feel most active. If you work out, I know I like to jog right around 3:30. 3:30, 4:30 is the perfect time for a nice jog in the afternoon. Some people, they like to do that in the morning. I hate jogging in the morning. It just does not work for me. In the morning, I like my coffee for like hours, and then maybe around noon, I like to start having some food or something. So all of that is controlled by your circadian rhythm. If you're one of those morning joggers, I don't get you. If you ever do a Ragnar, which is a race marathon thing, you have to jog at odd times. So it really tests your circadian rhythms. If you travel, same thing. People vary in this, of course, so it's sort of genetically based to some degree. And people can be morning people or evening people. And if you've ever had a job that's like night shift work, if you're a morning person and you cannot stay up late like that, right? This has biological roots. The suprachiasmatic nucleus is what it's called. It has sort of a 24-hour clock. This 24-hour clock is reset and can be controlled by light, actually. So the light boxes, they call them, can be used to help reset your circadian rhythms, because this, basically secretes melatonin. So some people take melatonin too, which is naturally occurring in your pineal gland, but if you flood your system with melatonin after a long flight, that's supposed to be a great way to get over jet lag. Anyways, this makes you go to sleep, basically, the circadian rhythm. So sleep is that conservation of energy, ability to integrate your memories that you just made that day So I always tell students, you have to sleep after studying. If you don't sleep after studying, your brain doesn't, connect all those dots. And basically you're working on almost short-term memory or working memory if you haven't slept after studying for a test. Of course, if you don't sleep at all, then sleep deprivation makes a lot of issues occur, including potentially illness, importantly. So people tend to get sick if they're sleep deprived. Anyways, the one you hear about most with sleep is rapid eye movement. That's where you get your pure sleep, right? Deep relaxation, and your muscles sort of relax a little bit. I think there's drugs released that control your muscles from moving too much because you can kick and stuff during REM sleep. They call it paradoxical because you have high brain activity and very low body activity, or seemingly low body activity. Anyway, so that's the best part of sleep. The worst part of sleep is things like insomnia, not sleeping, apnea, where it's about more like breathing. You wake up gasping for breath. That's bad, and people sleep with those sleep apnea masks to help control their breathing. Narcolepsy is the sudden sort of onset of sleepiness that I think is made fun of too much. I can't imagine suffering from that. It would be so scary, and it should not be made fun of at all. My nephew, I think, may have it. He's not sure, but I can't imagine having that. Anyways, periodic limb movement disorder is, I think it's the common name is restless leg syndrome. But another thing in sleep is the chemicals that are released during REM. If those are not released, then your body can move. That's sort of a different thing. That's the YouTube videos of the dogs who run in their sleep, which is actually kind of funny. Anyways, dreams are one of the sort of parts of sleep that are most interesting to some people. Most dreams are sort of negative, or people report mostly negative dreams, and maybe that they only remember the negative dreams. There's an interesting chart in your book. It's 10 point something, I want to say 10.1, where it's, what college students report about dreaming. And it's things like being attacked, schoolwork, of course, mostly negative stuff. Death, I believe, is in there. So it's a lot of negative stuff, sometimes happy stuff. But, we don't dream about everything that's going on, but a lot of people think we dream about certain stuff that we've experienced that day. Interesting studies have shown that people that lose their vision still experience visual dreams, and people that never had vision tend to dream of their other sensory sort of experiences. So it's really an interpretation or a resonance of maybe what we experience. Freud, of course, you have to mention Freud with dreams and dream analysis. He thought that these revealed unconscious thoughts and motivations. The latent and manifest content, manifest being what you see, like the symbols, latent being what that really means under sort of the radar. This is still used today. A lot of people believe in dream analysis. If you're dreaming about something a lot, it could be a worry that you have. And even the neurocognitive theory argues that activation synthesis is more like you're responding to body sensations. That's not as I think followed as much as the neurocognitive now. That's more the integration of what you've seen and heard and thought about recently. It's sort of what your daydream sort of default would be, or what they call the default network. Sort of those occurrences that sort of pop up in your mind when you're not trying to think of anything.